We propose a vision-based, near-time optimal deep sensorimotor policy to fly the quadrotor through a racing track. Our policy achieves a high success rate even though various visual disturbances appear. Our method consists of two key components: policy training and feature learning. The policy training is done via privileged reinforcement learning and imitation learning. We first train a state-based teacher policy that achieves near-time optimal performance. Due to the partially observable nature of the onboard camera, it is crucial to keep track of the next gate in view. To this end, we combine the path progress objective with a perception-aware reward. Then the flight skill is distilled into a vision-based student policy by imitation learning. For benchmark comparison, we test our policy on 3 tracks: circle, figure 8, and split S. The student policy does not rely on globally consistent position information. Instead, it infers the gate position implicitly and flies the quadrotor. Nonetheless, the student policy achieves the same success rate and comparable lap time as the teacher policy. The feature learning is accomplished by contrastive learning to enhance robustness. We use random convolution and random cutout color as training augmentations. The student policy is deployed in environments with 4 unseen visual disturbances: color changes, brightness changes, randomly placed blue boxes, and randomly placed objects with irregular shapes. Our vision-based policy still maintains a high success rate and comparable lap time even though the visual disturbances appear. We reduce the dimension of the image embeddings of training augmentations and test disturbances and visualize the comparison between them. The alignment ensures that the student policy receives matching image embeddings between training and testing and behaves robustly during testing.